All right, guys, we're going to get started with the next presentation. Stefan and Brian will be talking about the HackMeRF.
Hi guys, yeah, thanks for coming around for our small talk. I'm Brian, this is Stefan. We are both security researchers, analysts, penetration testers from Heidelberg. And we'd actually just like to introduce you to one of our small projects. After the talk, we'd love stacks of feedback concerning the project, because we're still in a, let's say, rather early stage, and there's still chance to change things and bring things forward. We both work for ERNW in Germany, which is a small IT security company. We do penetration tests, stacks of research, we're about 60 people. Small hacking workshop, and he did the very great thing of introducing us to the IME. Do all of you know what the IME is? No. Perfect. So Mike Lossman came by, introduced us to the HackMeRF1, and we needed a victim to hack. So he brought a small little toy, a little pink girl's pager. The stuff has been in the news a few times with various hacking projects. So the sweet thing about the IME is it's a toy. It's been off the market for a few years now. You can get it on eBay. You used to be able to get it for about you actually opened it, had a look inside, and if you've got a simple RF device, it does sub-gigahertz radio, and you can play around with it. It's just the perfect thing, both as a victim and as an attack tool. The way things went round, there was the first own firmware for it, the possibility to use sprites. Then it went on with a little spectrum analyzer, which yet again, if you've got a sub-gigahertz spectrum analyzer for under $20, that's round about what you want. Here you've actually got to say what Mike Lossman did was kind of actually bring the device really to its edge of existence. It's an 8051 architecture in there. The chip isn't very fast, and he's actually is able to do quite a lot of frequency hopping to actually create these diagrams. So it's actually, rather fascinating that the chip is able to do all that. Then the project that, raised the price of the IME was Open Sesame by Sami Kamka, which I guess some of you might know. And yet again, it was this nice little children's toy that you could actually use to, brute force and attack garage doors. And basically, that's exactly what we want. That's, we do quite a few courses, we do some teaching. And if you've got a little device with a keyboard on it that you can play around with, that's just awesome, especially if it's cheap. So, as said, the IME itself is based on the CC1110, an old chipcoin chip. Nowadays, they belong to TI. It runs on the 8051 architecture, so if you want to do a little bit more sophisticated radio stuff, not really perfectly possible. It comes with the LCD display, it's got the keyboard. The keyboard really is very nice to use, even for a little bit faster typing. One of the things that were done is actually, it comes with a small USB adapter. I think I actually skipped that. So the way this toy works is, it's for girls, and girls have to be protected on the internet. That's the way things go. So you've got this USB dongle, you connect it to the computer, you've got a software running on there, you've got chat server somewhere in the background. The parents are able to look after the friends list, And the kids then simply have this little device just to be able to chat to their friends. So, you've got a limited set of users that the kids can talk to, so nothing can go wrong. So this way, of course, the device is completely standalone. It runs on 2 AA batteries. Actually, I think 100% of the GPIO pins of the CC1110 is actually in use just to be able to have the keyboard on it. So the thing is really, used as far as it can be used. So as said, pros, of course, it's pink. It's portable, it's easy to use, it's simple. With the programming adapter that I showed somewhere here, you've got the debugging header on the back of it. You use pogo pins, the GIMME, or in future Michael Osman's GradeFET to program it, and you're ready to go and ready to have loads of fun. The cons, as said, you can't really get them anymore. As said, you can try to find them on eBay. You can be lucky, you can be very unlucky. I actually think the most expensive one that I've seen on eBay, the guy actually wanted $600 for this device. Not really perfect. And that way it's rare, it's hard to get. And if you want a device like this for the community, you've got to start with something new. And as said, ERNW, we've got our own conference in Heidelberg. We've got, quite a tradition of electronic badges. And we kind of finally made it into the RF world for an electronic badge.
Yep, as Brian already said, Troopers is our home conference in Heidelberg. We got a tradition now for several years for electronic badges. I think the first electronic badge was back in 2012. And finally, 2011, sorry. Not this long at ERNW as Brian. And finally we made a step into the RF world. As Brian mentioned at the beginning, we started working with software-defined radio when Michael was first time here at Heidelberg in 2014. So it was time for an RF badge. So we did this this year, starting at the end of 2015. The aim was to receive and show broadcast messages for the attendees of the conference. Sure to have some fun, to integrate it in different games while the conference was running. The concept was about an RF system on a chip, like we have now, or an Arduino paired with a sub-gigahertz radio IC, like a Nordic Semiconductor's NRF chip. By an RF signal, so the attendees had to find each other, and it worked quite well. We used Michael Osman's Yardstick 1s to broadcast the messages, which was using RFCAD on the laptop. Okay. The badge was inspired by the IMME, as Brian already said. We started evaluating different chips, different combinations of ICs. So finally we came up to the successor of the chip which was used in the IMME, which was an CC1110, I think. And this is the successor, this is the CC1310. So it was released in October 2015. We took the full risk. We didn't know if TI would release it just in time. So it was a big risk, and we got it end of October. We had many problems with the chip, as you will see later on. Yep.
And that's actually, we're trying not to do a lot of bashing, but we actually had quite a lot of fun during the first few steps. the chip was announced, so went to TI, the classical paperwork to get a little bit of previous information. And actually the documents that we got under NDA were the 4-site data sheet that was already on the website for 2 months. So actually our first prototype was really just based on, the footprint with the preliminary pin-out and a little bit of information. And we kind of, really had luck with our sales representative. His main field actually were low-power DC-DC converters. And he was the guy coming in to tell us about, RF chips. So that kind of went well. He told us he'd be able to get us a few samples, pre-market release, the classical stuff. Actually, in the end, the samples that we had ordered over the TI website arrived, I think, 2 weeks before the samples we had ordered under NDA. So, it was kind of the perfect time frame. We had about 5 months for the overall project, and about 2 months just went into waiting for samples. So that was real fun getting into this chip.
Yep. So that's that. Another thing was how do we communicate with people? How could they use the device? On the conference, nobody wants to attach his badge the whole time on his laptop. So we were really lucky with a cheap TFT LCD screen with a touch. And this worked quite well. We got no problems, except of the driver, which we had to write for the Kontiki real-time operating system. And we used also, which was a big cost factor, lithium polymer batteries as a power source. Okay. Actually, this was the badge. So it was integrated in the corporate identity, style, and the look for the conference. We got an onboard PCB antenna and also a connector for the SMA antenna. Some footprints like for micro SD cards and I2C EEPROMs and SPI EEPROMs. Okay, this was the back. This was, this year's conference style the Troopers team chose. So it was kind of James Bond, spies, and evil persons. Yeah, that's why we came up with this design. So Brian wanted to show us some schematics.
The schematics that we made actually were, comparably simple. I'm just trying to shift them over if I can find my mouse. The CC 1310 actually works with a rather small amount of we're actually able to deactivate the DC-DC for the display. And as such, if the badge went into kind of a standby mode, we really save stacks of energy. The CC1310, which we'll be showing in a second, actually has a M3 and a M0 processor in them. So even there you can put the M3 completely to sleep and just have the M0 waiting. So it's rather nice even for long-term use. And for communication, we went for a very simple USB UART bridge by FTDI. Even there we had the great thing, you know, the CC1310 can be flashed via serial, so it's got a serial bootloader. And if you actually look through the datasheet, you'll see that absolutely all peripheral pins can be mapped to every other output pin, you know, the way it is with modern CPUs or with modern SOCs. The only thing that you can't remap are the two serial pins for the bootloader. And that's actually in the datasheet somewhere on page 700 and a bit. So even if you go through these 3 pages of tables where EEPROM, we've got an expansion header at the bottom, just, you know, if you want something to play around with. Funnily, actually, the feedback that we had concerning stuff like the SD card reader was the device had so much potential that wasn't used. So instead of the people thinking about grabbing a soldering iron and adding it, there was a little bit of, yeah, flaming, but we worked our way through that.
Okay. As I already said, okay, I think the slide was already mentioned. Test. Okay. Okay. Like already said, we had a PCB antenna on the top, an SMR connector, which could be optionally used by the users, and the CC1310 was hidden behind the display, so it couldn't be damaged in an easy way if people were walking around hitting each other. Yeah. Okay. The batch consisted of a few parts as the CC1310, the FTDI FT231X, which was not just a USB serial bridge. It also got some charging support for the LTC3554. We've got JTAG and the serial bootloader. Brian also already mentioned the problems we had with the UART pins. We've got a real-time clock, as TI says, a true random number generator, an AES module, over-the-air capability, and an integrated temperature sensor.
If I may just ask, does anybody here actually know what the feature OTA means with modern RF SOCs? I actually wasn't sure. I actually thought that it was something like a method that you could do firmware updates. The OTA, all that the OTA capability actually means is the fact that the chip is able to write flash pages while it's running. So that's actually everything that it means. There is actually no functionality for OTA implemented. The only thing that you can do is basically receive a firmware file from somewhere, overwrite a certain flash page, link it back to the first boot page. It is nothing else.
So we had lots of pitfalls. In the blog post of the conference, Brian already wrote about it. So we had not supported frequency bands at the release of the chip. The CC1310 only supported the 800 MHz ISM band and the 900 MHz ISM band, so it could work in Europe and the US. Every other ISM band was not supported and is still not supported by TI. Also, there are not all modulations supported. So there is only 2FSK, 4FSK, DSSS, and OOK. GFSK is not supported, as an example. Yeah, and also not the digital features like automatic listen before talk and clear channel assist.
Now the important part is we've got it here on the pitfalls. All the functionality that we've spoken about is in the datasheet, but it's simply an errata document by TI that came out after the chip release, saying, you know, the features are in the chip, but we aren't really ready with specifying the features and the ranges. So you won't be able to use it until we publish an update for the M0 firmware. So basically it's a question of waiting and hoping that...
Maybe the block. Okay, another pitfall was the RC oscillator, which was not working, still not working, also not working on other chips of this series, like the CC1350. Also, the data rates are only supported up to 100 kilobit per second, not 2 megabit as TI announced earlier. Still the current state. Also the TI RTOS, which we wanted to use because every driver lib is already included, got some strange, like they say, a BSD-like license, which forbid to release binary code, if I remember correctly. So we switched over to Contiki, which is an IoT RTOS. As I said, status today is unchanged. I had a look at the documents yesterday and still on the same state like back in March on our conference. Yeah, we are waiting for TI to finally release the whole things they announced. But yeah, here are no updates. Yep, the Cortex M0 pitfalls, there's no firmware you can modify in an easy way as the vendor. Yeah, there are some update files in the Contiki repo, which seems that they could be modified. So maybe we'll have a look at it in the future if we need access to the M0 for power saving or for getting faster channel switching. Okay. firmware is Contiki RTOS. It works in a single process for the whole thing. Contiki also supports multi-threading, but we didn't use it by now. Yeah, it decodes the data it receives. So the batch on the conference was programmed receive only, but we got some people, which were transmitting while the conference and spoofing some data transmissions. So it was quite fun, and that's what we wanted people to do. Okay. We transmitted the broadcast messages like what talk is on which track next. Working? Okay, I think I have to speak a little louder. Yeah, and also the name change game I mentioned earlier. We used 2FSK because we did not have a lot of choice because the other modulations were not supported on the release. So finally we got a good first prototype after the pitfalls were handled. Okay, I think Brian will show you some demo.
So basically, I hope it's fine if I don't use the microphone, loudness-wise. The easiest way to actually transmit data that we found out was, as said, using Michael Osman's Yardstick 1. You can use RFCAT directly. We've got a small Python script, which will then eventually just actually transmit a raw message over the air, which will then be shown on the displays. As a quick demo, we luckily didn't think about actually taking a camera to show the badges on screen. But Mr. Motel. So these are actually the devices that we used during the conference. As you can see, they show my cool name. And then with a very simple script, mic's broken. Yeah. It's going in and out. The cables loose as it seems.
In and out, you say? Seems perfect. Okay. This one seems like it's basically off, but yeah, like it's not getting any pickup at all on that.
And now getting to the actual points why we are here. So
try and make sure.
Test.
As said, we like the IME. It's a great toy. During our conference, we basically did quite a bit of work towards a successor for it.
Yeah, that's fine.
And that's basically the project why we're here today. Following Michael Osman's naming scheme,
You slip that in your pocket.
we actually decided to simply give it the name HackMeRF as both a victim, a teaching, and also a hacking device. So, quick disclaimer here is the work that we've shown so far was, our business time creating a badge for our internal conference. Everything after now is kind of what we made out of it. It's just running into a private project, or rather we're hoping to actually turn it into a community project. Luckily, we've got a little bit of support of Michael Osman, who's already helped us doing some firmware and is playing around with it. We've also got 2 prototypes lying with Semikamka, who wanted to have a look. So everything after here is the interesting stuff. The HackMeRF is intended to be an IME successor. So actually what we want is we want a small handheld device that's standalone, being able to do sub-gigahertz RF stuff, have the display, have a keyboard on it, and work our way through that. You know, of course, the optimal version would be having the own case, create own molds, having rechargeable batteries in there, have it perfectly nice and neat. But the way it is with new projects, something like that to start with is simply unrealistic. So at the moment we are working on what we call the HackMeRF Lite. Simply take a PCB, add the display, go for the CC1310. We are hoping that TI will actually release a few software updates in the near future. The support of all bands was announced for June this year, so we are hoping that they won't just drop the chip. We want to add a little bit of external flash, want to have an SD card slot on there. Actually, so if you have collected certain samples or you want to have some scripts running on there, that you can store it on there. Have USB UART as a power supply, you know, micro USB slot, have a few straps so that you can add something like an external battery, and an expansion header. So yeah, that's currently the thing that we're working on. We've decided to also add a keyboard, simply because if you're on the road and you want to play around a bit, a keyboard always is perfect, especially if you want to send arbitrary messages. For the keyboard we've got two concepts. So the first one is, I don't know if, do you know these Snaptron buttons? There's something like small metal domes that you actually place on a PCB and that you can then press as a keyboard. I've got quite a few samples of them at home. They are rather comfortable. But the alternative that we are actually aiming for are these rubber mat keyboards as you've got in TV remotes. And of course in a TV remote you've usually got the whole plastic case. But with a little bit of playing around, we actually worked out that it's enough if you've got a PCB underneath with the contacts, have the rubber mat and have another PCB with holes in it on top of it. Add a few screws, fixate the whole thing, and you've actually got a really nice rubber keyboard to work with. And also, you know, for a small project it's affordable. A mold is something like about $700 and you'll be able to produce, I think,
900.
about 900 rubber mats with it, just for a prototyping process. So that's still something that we can afford. And as we're in contact with Michael Osman a lot, it kind of shows, following the making good fat great again movement. Initially we had a few discussions with Michael Osman, you know, actually making the device a good fat. Adding the MSP processor to it so that you've got a little bit more of power on it. But eventually we actually worked out, you know, the ARM Cortex-M3 should be enough for most things. And adding the extra MSP simply would raise the price of the overall project. So we are going for the easy solution now. We'll be adding the footprints so that the HackMeRF will be a simple great fat neighbor. So if you want more power, you attach a great fat. You can do whatever you want with it. You can still power it from a portable battery. And otherwise, if the Cortex M3 is enough for what you want to do, you know, you're up and running in a few seconds. Yes, so the current or future plans, depending on how you want to call it. We want to set up the whole thing. We've got our basic schematics. We're just in the middle of creating a new layout for the HackMeRF, for the Lite version. We know that we've still got to do some work on the antenna design. Transmitting with it on maximum power, I think we currently are reaching about 8 to 10 meters, which for sub-gigahertz simply isn't a lot. And actually, as we only wanted our Troopers badge to be able to receive data, we didn't really care about the antenna a lot because the transmitter was strong enough. So what we're working on is creating a proper antenna design, increasing the reach on that. And yeah, we are currently putting together the website. It's not up yet, but it will be up in the next few days. So if you want to follow us, if you're interested, feel free to visit hackmerf.org. We will also have a look at the CC1350. The CC1350 has the same sub-gigahertz radio as the CC1310. It's got the same Cortex M3 processor, but they actually also added a CC2410, I think the naming scheme should be. So it's actually also got a 2.4 gigahertz radio in it. So, as we are making the device, we're still, rather at the beginning. We'll actually try to see if we're able to have the sub-gigahertz and the 2.4 gigahertz in the same portable device. Simply because, it's a little bit more power. The chip, I think, is about $2 dearer, so it's something like $6 instead of $4. So that's probably worth the hassle and worth the extra money. The biggest to-do that we still have is finding a proper contact in TI that will actually help us, and somebody who might actually be able to tell us when the silicon errata will be put into place and when the great updates will come that will actually make the chip usable the way it's in the data sheet. So, it's not that we want new features, we just want everything that's in the data sheet. We are going to hit Kickstarter soon. We're currently aiming at middle to end of September, where, we don't want to kick off. Okay. We don't want to kick off a ginormous project directly, but we actually want to, produce a series of maybe 100, 200 devices to get a few into the community. Price-wise, the way it looks at the moment, even with a small amount, we should be staying under about $70. We aren't perfectly sure yet. We've got to put everything together. So we hope that it's actually still affordable. So yeah, that's currently what we're working on right now. Last but not least, what I've got to do, I've got to thank a few people who've been helping us with the project. Christopher Scheuring and Olli Gebhardt and Timo Schmidt are two of the guys working with us at ERNW who actually also put quite a lot of sweat and blood into the overall project. And yeah, as such, thank you for listening. Feel free to follow us on Twitter or wait for the website to come up in the next few days. And now after the talk, we'd be happy for any kind of feedback, any recommendations. As said, we're trying to work rather closely together with Michael Osman to get a little bit of inspiration from that side. But as in the end, it's supposed to be a community project. We need you, we need your feedback. And thanks for listening.
Thank you.
There might still be a few people from Great Scott Gadgets running around here. Michael Osman gave a talk at Black Hat and they just handed out the hats. So you might be lucky by contacting him.
Are you planning a port for external antennas?
Yes, we've got the SMA port already in the schematics and on the PCB, so that's something that we surely need. We're actually also looking into Michael Osman's design on the Yardstick 1 because he's got the amplifiers on there. So we're actually looking if it's feasible for us actually to transfer the same circuit onto the device. Actually just to get a little bit more range and have a bit more fun with it. Perfect, thank you.
Thanks.